Hello everyone. This is a quick video to demonstrate the difference between a pocket routine, a contour using cutter compensation, and an engraving routine. So I've opened up Mastercam, and in Mastercam I'm going to create some simple geometry. So I'm going to press my F9 key to bring up the axis lines. This will help me find where my origin is. And I'm going to click on the wireframe tab up here. I'm going to click on rectangle. And when the rectangle drop-down menu comes up, I'm going to make sure that I have anchor to center selected so that I can anchor the center of this rectangle on the origin and drag it outward. We'll set the values to be 4 inches by 3 inches. And we'll say not OK, but rather OK and create a new operation. That's the blue check mark. That allows me to leave this open so I can do my second rectangle on the inside here, slightly smaller. This one we'll set to 2.5 inches, and we'll make it 1.5 inches in the other direction. And now we'll say OK with the green check mark. Now because we're using an end mill, the end mill is going to naturally, because it's round, leave a corner radius. So let's create a corner radius that's slightly larger than the end mill itself. The end mill we'll be using will be a 3/8 end mill. So I'm going to come up here to fillet. I'm going to say fillet entities. The default is 1/4 of an inch, which is larger than half a 3/8 end mill. So I'm going to use that value, and I'm just going to click the 2 lines on each corner to create the fillet radius. Once the fillet radius is created, I'll say OK. Lastly, I want to create a letter for engraving on the inside here. So I'm going to come up, and still in the wireframe tab, I'll click on Create Letters. I'm going to use the first initial of my name. And then I'm going to click on the base point reselect button so that I can center it right here in the middle. I'll say OK, and I'll press the F9 key to turn off the axis origin. And now if I press and hold down my middle mouse button, you can see I've drawn 3 pieces of geometry right at the 0 level. I'm going to right click and go back to my top view. I'm ready to create my first toolpath. So the first toolpath that I want to do is a pocketing toolpath. That's where we're going to come in here with a smaller cutter and spiral outward and cut all of the material out within this inner rectangle. To do that, we have to make sure that our toolpath tab is selected, and we need to select a machine. So I'll come up to my upper tabs here. I'll click on the machining tab, click on mill, and I'll choose the default mill. I'll right click just below that, go into mill toolpaths, and I'll go down until I find the pocket toolpath. This is called the chaining menu, and the chaining menu helps you select the geometry that you wish to machine, and it does that by various methods. As you hover your mouse over each one, it'll tell you the method. The chaining method is the one that's probably more popular, and what it does is it allows you to connect geometry that's already attached to other geometry in one single click. Now where you click when you're chaining makes a difference in the direction that the chain will go, and that direction the chain goes also can affect the direction the cutter goes. So for instance, if I click down here on this line, and it will make a chaining direction of counterclockwise, which is climb milling, the preferred method for CNC. Now if I made a mistake and the arrow is going the wrong way, I can actually click over here and reverse it, and now it would be doing a conventional cut. The cutter will be going around in a clockwise direction. However, I do want it to go counterclockwise because that's the preferred method, so I'll reverse it back the other way, and then I'll just say OK. From here, the toolpaths menu pops up, and we need to fill in the information about the tool that's going to be doing this particular operation. We'll click on Tool, we'll click on Select Library Tool, and if the end mills are not being shown here, perhaps you have a different style tool being shown like drills, you have to click on the Filter button. And on the filter button, you can filter what tools are being displayed. So you can say all of them displayed, all different types, none of the types, or in this case, I just want to see the end mills, and I'll click OK. We'll be using a 3/8 end mill for this operation, so I'll just come down the list until I find the 3/8 end mill, and I'll click OK. Now, the 3/8 end mill is also the tool that you'll be using for your Homework 3 mold project. So that tool for the mold project is actually tool number 5. So I'll double click in here and I'll set this to tool 5, and I'll press the tab key. That will populate the length and the diameter to be the same as the tool number. Remember, these all have to match. Now I'm going to set the feeds and speeds, how fast I want to drive this cutter around this pocket routine. Remember, we talked about feeds and speeds in our first lecture. So I'll set the RPM here to 1600 RPM. The feed rate can be 12 inches a minute. And the other thing we'd like to do is when we exit out of here, we're going to say rapid retract. That'll pull it out of the pocket when it's completed rapidly. We'll put a comment here, and I'll call the comment pocket. Next, I'll go to our cut parameters. In our cut parameters, this is where we describe how much material we want to leave for the finish. In this case, we don't want to leave anything for this, in this operation. We're going to complete the operation completely. So I'm going to come in here and say 0 stock on the walls, 0 stock on the floors, and when I press the enter or tab button, you'll see that the stock disappears. We want to make sure that our climb direction is selected for pocket routines, and also that we're using a standard pocket. Now we'll click on the roughing tab here. And on the roughing section, this is where we can pick the different style of pocket we want to cut. There's many different pocket routine styles that you can choose from. The two most popular that you'll probably use would be zigzag and parallel spiral. As a matter of fact, I think parallel spiral is what is going to be used for almost all of your old projects. So let's choose that strategy for this example. So I'll click it. And then this chooses how the tool overlaps itself. So in order for a pocket to clear all the material out, the tool needs to be able to step over, but it can't step over its full diameter. It'll leave material standing. So in this case, it's set to a 50% step over value. We'll accept that. It's the default. And then we're going to click on entry motion. This is how the tool is going to enter down into the material. Because end mills don't like to plunge all the time unless they're special end mills, we're going to use this helical entry method. So the helical entry method, so we're not cutting a bunch of air here coming down. We're going to shorten this Z clearance amount up to be 0.01, 10,000ths of an inch just above the part. Then it can start the helical down to its full depth. So we're going to click on finishing next. And this is going to leave 10,000ths of an inch on the walls and floor for the finishing operation built into this pocket cycle. Cutter compensation will have the computer compensate for the cutter itself and its diameter. And so the next thing we're going to choose is the lead in and lead out. This is how the tool will lead in to cut the final contour around the walls to take that last 10,000ths. We'll set this to be a perpendicular entry method because that's usually best. The length that we want to enter in, we're going to put that to a value of 0.1. And the radius that we'll be using will be the radius of the tool, and we'll be entering at 45 degrees. So the values I just set, perpendicular means it's going to try to come in as perpendicular to the line that it's going to be entering in as possible. This length here is the lead-in amount of 0.1, and the angle that the lead-in is going to be set to, and then the radius that it cuts will be right here. Now we want to do the same thing when we exit, so rather than having to key in all these values again on the exit side, we can use this little copy button, which will copy all the values from here to here. The depth of cut we're going to leave off, so make sure the red circle is on. If it is not on, that means this check mark is on. You want to take the check mark off. Because we're only going 0.1 deep with this, there's no need for us to do it in multiple depths of cut. Same with the breakthrough amount. We're not going to use that, so make sure that red circle's on. The linking parameters sets up how the tool will enter into the material and then exit out of the material. We want to turn on clearance, and we want to make sure that all of these values that we're about to give it are in absolute values. We talked about the absolute values in our first lecture. Let's set our clearance amount to 1.0. That's the amount that it'll actually rise up at its highest point. Our retract amount will leave at the default 1/4 inch. That's what it would do if we were doing multiple pockets. It would come up 1/4 inch to jump over things. The feed plane is how far or how close to the top of the part it will wrap it down to before it begins to feed into the material. We could be closer. We're going to set that to 0.1. The top of our stock is going to be 0. That's where we're setting our origin. And the depth needs to be a negative value because we're going to be going from the top of the stock 0 negatively into the stock. So we're going to go minus 0.1. From here, because we're cutting plastic with our molds, we also want to make sure that we turn the coolant on. So go to flood and turn the flood on and then say OK. Your toolpath is now created for you. If you want to see what that looks like, simply click on toolpath here and the play bar will show up. Click play. and you'll see the tool helicaling down. I'm going to press and hold my middle mouse wheel, and as I'm holding it down, I'm rotating it dynamically so you can see how this thing is going down into the material. Now to speed this up for the essence of time, I'm just going to pull this arrow on the top here faster to the right, and you can see that it came down, it cut the pocket, and then it came in and ramped in and cut the final 10 thousandths off, and then it came up to our clearance amount of 1 inch above. So this is a simple pocket routine, and it cleared all of the material out from within this boundary that we gave it. I'm going to right click and go back to our top view, and I'm going to say OK on our toolpath play bar so that it turns it back off. And I want to clear this toolpath off the display screen so that it's not confusing us. So in Mastercam, there's a toggle. If you press and hold the Alt key and then press T, you can toggle the toolpath on and off. So I'm holding the Alt button now and pressing the T button, toggling it on and off. Our next routine is just going to be a simple contour. We just want to contour this inner contour. But when we do that, we want to use cutter compensation. And we talked about cutter compensation is where we drive a cutter around a contour, but either to the left of the line or to the right of the line. If we're to the left of the line, we're climb cutting, the preferred method for CNC machining. And if we're to the right of the line, then we're conventional cutting, which is cutter right, which is also proper for certain types of machines. I'm going to right click in the toolpath area, go to Mill Toolpath, and this time I'll click Contour. Again, the chaining box appears. I'll leave it on the default chain and chain exactly like we did in the pocket. I'll say OK. And then under Tools, we're going to use the same tool number 5. But because this is a different type of operation, some of the default values from the last operation didn't get carried over. So make sure that tool 5, length 5, and diameter 5 is set. And let's set our RPM back to 1600 and our feed rate back to 12 inches. Let's make sure Rapid Retract is turned on. And for the comment for this one, we'll type the word contour. By the way, these comments do show up in the program, so it's a great prompt for you or the operator to tell the operator either what's going on or specific instructions that you want followed. After that, we'll go to our cut parameters, and this time, rather than we'll use the computer, and we'll make sure that our compensation direction is set to the left. So this little graphic will show the tool to the left of the line. Also, please make sure that the stock to leave on the walls is set to 0 and on the floor. And our contour type in this particular case is a 2-dimensional or 2D contour, meaning we're just going down to a flat depth and cutting around a contour. We're not trying to contour a 3D surface. The depth of cuts, again, we're going to leave that off. Our lead in and lead out needs to be set back to perpendicular. Again, this value to 0.1. This value can be 375. We'll make our lead in angle 45, and we'll copy those values over to the right side of the screen. Linking parameters, we'll turn on our clearance. Again, make sure that everything is set to absolute values. The clearance will be 1.0. The retract will remain the same. Feed plane 0.1. Top of stock 0. And again, negative 0.1 for the depth that we want to go. And lastly, the coolant needs to be turned on to flood. And we'll say OK. Our contour toolpath flashes on the screen for a brief second to see what it looks like. Again, click on toolpath and run your little play icon here. And you'll see it lead on to the part and lead off. And remember, we talked about cutter compensation needs to have a ramp on, a lead on and a lead off in order for it to work properly. It needs to engage itself. You can't just start cutter comp right on a line. It will end up cutting a crooked line. So you start off of the work, lead on to the material. Here, I'll play this again so you can see it. And you can see how the tool stays to the left of the line because we're using a climb cut operation. I'll say OK on this toolpath, and then lastly we want to do some engraving. So I'm going to right click, and engraving is nothing more than a contour without cutter compensation. We want to drive the tool right down the center of this contour, and to do that we'll right click in Mill Toolpaths, click Contour again. Instead of chain this time, let's use the window method. With the window method, I'll just click my left mouse button, hold it down as I drag a window around the letter R, click again, and then the prompt here says sketch the approximate start point of where you want to start machining. I want to start down here. Now it selects my geometry, and then I say OK. back into the tool menu we go. We click on tool. Now for engraving, we can't use a big fat end mill like the 3/8 end mill. Instead, we're going to use a center drill. It's tool number 3 for your mold projects. So I'm going to go to select tool. I'm going to use the filter command, and I'm going to turn everything off and make sure that center drill is in fact selected. Now it happened to pick it correctly for me this time, but just in case it doesn't, that's the way that we go around and pick the proper tool type that we want. So center drill is selected. I'll pick the very first center drill. And on your mold programs, the center drill will actually be tool number 3. So I'll set 3, press tab, make sure it populates to the length and to the diameter so that they all 3 match. And for the engraving, again, let's set this up a little bit faster. It's a smaller tool, so let's go 2000 RPM. And let's still engrave at 12 inches a minute. Our rapid retract is automatically selected, and here I'm going to type the word engrave for our comment. Next, on cut parameters, we don't want to compensate the tool to the left. We want that tool to drive right down the center. So we're going to come down here and we're going to turn our compensation off. And notice the graphic now displays the tool running down the middle. Stock is set to 0. Depth of cut is turned off. Lead in, lead out also needs to be turned completely off. We don't need it to lead on and lead off. We're not using cutter comp. Breakthrough is off, multipass is off, tabs are off, and back in linking parameters, this should all be set to the same values as last time, except our depth needs to be selected. Now we've cut this pocket out at 100 thousandths deep, that's 0.1. We want to go 10 thousandths additional deeper with this engrave. So we need to add that value to the minus 0.1, and so our negative 0.11 minus 110 thousandths would be the proper depth to go 10 thousandths deep with this engraving into the bottom of that pocket. Again, coolant when you're engraving is optional, but we'll leave it on, and I'll say OK. Now I'll click on the tool path, and I'll run the simulation, and you can see that the tool comes down, lifts up, and does the final engrave. I'll play that once again so that you can see exactly how it did it. Comes down, lifts itself up, comes down, and connects the last part of the R there. I'll right-click, bring it back to the top view. I'll say OK here. And now I want to show you what this looks like when you verify it. What would it look like in an actual cut part? So in Mastercam, we're going to hit the plus sign here under Properties, and we're going to go to the stock setup. And I'm going to describe the stock that we'll be using. That's this outer rectangle. Now, I don't know the values. I can't remember what I put in exactly, so I can't key them in. So instead, I'll use the Select Corners option. I'll pick the upper left corner, and then I'll drag down here and pick the lower right corner. It fills in the values for me automatically, except for the thickness of the material. Now, your mold will be 0.375 thick. So we'll put in that value and say OK. Now, rather than using this method where we clicked on tool path to get the two-dimensional kind of display, that's called backplotting, we're going to click on the 4 blue dots here, which will select all of our tools in the operation. And we're going to come up to the top menu bar here and click Verify Selected Operations. When we click that, that will open up another window with the Verify software that loads. I'm going to right-click in here and say set it to an isometric view. I'm also going to get rid of this geometry that's on the screen here. So I'm going to click up here and turn it off by clicking on wireframe. Here's where we can set the accuracy of what it looks like when it does this simulation. So you can set it between performance and precision, and also whether it goes slow and fast. And these two kind of work together. And on more difficult type 3D simulations, you might want to play with these values to get it to give you the optimal display. So I'll set our precision up just a little bit, and I'll slow it down so it doesn't happen too fast, and I'll click play. So you'll see the tool will come down and do the pocketing, finishes the pocket, does the contour, and then does the engraving. So this is exactly what we wanted. We wanted to go 10,000 deep into the bottom of the pocket. That's why we chose 110 deep for the engraving. We went 100 deep with the pocket, and then we did a contour with cutter compensation. So that is actually the 3 different types of tool paths that I wanted to show you, because this is what you'll be using for your mold projects. I'll also do a video showing you how to do a simple mold that just does pocketing only, and also another mold that combines the pocketing with the engraving, so that you can use this video as your precursor, and then when you go into the mold video, it'll kind of refresh your memory as you go through those operations. This should make it more solidified in your mind and give you a greater chance of success at creating this program. So I'm going to X out of this verification. I'll right click and go back to my top view, and I'll end the video. Thank you for watching.